An equinox is an astronomical event that happens twice, once in spring and once in autumn, each year when the tilt of the Earth's axis is inclined neither away from nor towards the Sun. If you live in the northern hemisphere, you probably use the terms March equinox and vernal equinox interchangeably because, in this region, the March equinox marks the beginning of spring and all the seasonal changes that come with it. In the northern hemisphere, the March equinox is traditionally celebrated as a time of rebirth, with many different cultures celebrating spring holidays and festivals such as Easter and Passover around the time of the equinox. In the southern hemisphere, however, the seasons are reversed. That's why the March equinox symbolizes the beginning of autumn and therefore is called the autumnal equinox. To avoid confusion between the different hemispheres, astronomers use the terms March equinox and September equinox. In everyday life, however, you're more likely to hear about the vernal and autumnal equinoxes. The word equinox is derived from two Latin words, equus means equal and nox means night. At the equator, the sun is directly overhead at noon on these two equinoxes. The nearly equal hours of day and night is due to refraction of sunlight or a bending of the light's rays that causes the sun to appear above the horizon when the actual position of the sun is below the horizon. On the days of the equinoxes, the Earth's axis is perpendicular to the sun's rays, meaning that all regions on Earth receive about the same number of hours of sunlight. In other words, night and day are, in principle, the same length all over the world. The equinox does not always fall on the same day each year due to the fact that the Earth orbits the Sun on a slightly elliptical path. At the moment of the equinox, the ecliptic and the celestial equator intersect. The ecliptic is the Sun's path across the sky. The celestial equator is an imaginary line extending from the Earth's equator into the celestial sphere. They are inclined to each other at 23.5 degrees. If there were no inclination between them, there would be no seasons and solstices, and we would have the equinox all year round. The nearly equal hours of day and night is due to refraction of sunlight or a bending of the light's rays that causes the sun to appear above the horizon when the actual position of the sun is below the horizon. Additionally, the days become a little longer at the higher latitudes because it takes the sun longer to rise and set. Therefore, on the equinox and for several days before and after the equinox, the length of day will range from about 12 hours and 6½ minutes at the equator, to 12 hours and 8 minutes at 30 degrees latitude, to 12 hours and 16 minutes at 60 degrees latitude. The phenomenon of the precession of the equinoxes and the long-term variations in the shape of the Earth's orbit mean that these durations change gradually over centuries and millennia. For instance, the northern summer is currently the longest of the seasons, and its duration will continue to lengthen until the 37th century, at that point reaching close to 94 days. It will then embark on a slow decrease, but will nevertheless remain the longest season until the year 6430, when autumn will snatch the title away. Here's an interesting fact. Equinoxes are the only 2 times yearly that the sun rises due east and sets due west for all of us on Earth. While the sun passes overhead, the tilt of the Earth is 0 relative to the sun, which means that the Earth's axis neither points toward nor away from the sun. During March it is springtime in the northern hemisphere, and March equinox is called vernal equinox and spring equinox, while it is an autumn time in the southern hemisphere, and March equinox is called autumnal equinox and fall equinox. In other words, on March equinox it is springtime in the UK, the USA, Canada, Russia, India, and China, while it is autumn time in Australia, Argentina, Chile, New Zealand, and South Africa. Similarly, during September it is autumn time in the northern hemisphere, and September equinox is called autumnal equinox and fall equinox, while it is springtime in the southern hemisphere, and September equinox is called vernal equinox and spring equinox. In other words, on September equinox it is the autumn time in the UK, the USA, Canada, Russia, India, and China, while it is springtime in Australia, Argentina, Chile, New Zealand, and South Africa. Why does the date vary? The date of the equinoxes and solstices varies because a year in our calendar does not exactly match the length of the tropical year, the time it takes the Earth to complete an orbit around the Sun. A tropical year is approximately 365 days, 5 hours, 48 minutes, and 45 seconds long. It can vary by up to 30 minutes each year. Why does the Sun move north and south? During the course of a year, the subsolar point, the spot on the Earth's surface directly beneath the Sun, slowly moves along a north-south axis. Having reached its southernmost point at the December solstice, it starts moving northward until it crosses the equator on the day of the March equinox. The June solstice marks the northernmost point of its journey. The subsolar point moves north and south during the year because the Earth's axis is tilted at an angle of about 23.4 degrees in relation to the ecliptic, an imaginary plane created by Earth's path around the Sun. In June, the northern hemisphere is tilted toward the Sun, and the subsolar point is north of the equator. As the Earth travels toward the opposite side of its orbit, which it reaches in December, the southern hemisphere gradually receives more sunlight, and the subsolar point travels south. Understanding Earth's orbit. We know that the changing position of the Sun in the sky is down to various factors involving the movement and position of our own planet over the year. Earth is 150 million kilometers from the Sun and orbits it along a slightly elliptical path at a speed of 107,208 kilometers per hour. One orbit takes approximately 365 days. Our planet isn't upright in its orbit. It's tilted at an angle of 23.4 degrees and spins on an axis at a speed of 1,670 kilometers per hour. There are only 2 times of the year, one in March and one in September, when the Earth's axis is tilted neither toward nor away from the Sun, resulting in a nearly equal amount of daylight and darkness at all latitudes. At 2 points in the year the Sun will illuminate the northern and southern hemispheres equally. These are known as the equinoxes, the autumnal equinox and vernal or spring equinox. It's the moment at which the plane of Earth's equator passes through the center of the Sun's disk, or the moment that the Sun passes the celestial equator. Wherever you are on the planet, everyone experiences the equinox at the same instant, even if the date is different. It seems that while humanity now boasts modern calendars to keep track of our seasons in the Sun, where our planet spins in relation to that big, bright star in the sky remains a method worth recalling.